Hello, my name is Kenny Gorman, co-founder and CEO of Eventador. I'm just going to go through and give you a pretty quick overview of how the Eventador platform works and how you can build a stream processing job from end to end. We're going to start with our stream processing example repo. In this case, I'm using the fraud repo, and it's just a hypothetical payment flow, a streaming payment flow to show authorizations from various locations and which ones potentially might be fraudulent. All right, so let's get started. If you're doing this and following along, you can clone this repo. It's the Eventador repo / Eventador examples / fraud. And the README there tells you how to do everything. So we're just going to kind of follow along here. So I've already cloned this repo, so I'll have to do that. I'm currently in that directory, the fraud directory. I've already set up my environment variables for my Kafka cluster that I'm going to be using. And I'm going to go ahead now and just build the fraud generation program, which is just a simple piece of Python that creates transactions that are both good and fraudulent. All right, now I'm just going to go ahead and run that. So I'm just going to Docker run, and I'm going to change it so we can see the output here. All right, and so you can start to see the topic already exists. Now it's putting a whole bunch of transactions in there, and every once in a while it's creating some pretend fraud examples. All right, the next steps are to create a new environment with Eventador, and I've already done those things. So we can go ahead and just start building a job. So I'm going to go to the Eventador console. You can log in there at eventador.cloud and click on the SQL Stream Builder item on the left-hand pane. And that brings up a compose window. And that window is going to allow us to paste SQL directly into it and run a fraud processing job. So let's go ahead and create a job here. That name is fine. I'm going to run it in my 5.0 cluster. And I don't need a sink. A sink is typically where I'm going to send the data. In this case, I'm going to materialize it into a view. So we won't be using a sink for this example. Real quickly, let's go ahead and paste the SQL from our example here. So this is using the match recognize syntax in SQL to actually figure out which transactions have a starting value that then climbs over a time period and has 3 different steps to its measurement. So for instance, we're going to partition by card ID. We're going to order by the timestamp. And then we're going to measure those 3 different timestamps in an interval of a minute. And if the query matches the pattern of 0 to 1000, then 1001 to 2000, and then above 2000 within a minute for each one of those steps, then that would be considered fraudulent. So it's a really nice way to actually do CEP in SQL, and SQL Stream Builder supports it, and it's super, super powerful to use. All right, so that's the SQL statement I'm going to use. Just real quickly on the authorizations virtual table, that is defined in virtual tables. Let's just look at that real quick. If I go down to authorizations and I edit that, you'll see I've set this up ahead of time. And all you do is you point at the cluster you're using for Kafka, you name it, you pick the topic, you pick the format, in this case JSON, and then you can detect schema down here at the bottom. It'll automatically build the schema for you. Essentially duck typing every field, okay? And then transformations, I don't have any transformations here. If I wanted to transform that data on input, I could actually write this in JavaScript here. In our case, it's pretty simple and straightforward inputs. We don't need to do any of that. So I've already set that up ahead of time. Let's go ahead and run the query. So I'm going to go back to the compose window, and now I want to actually create a materialized view. So the query is not yet running. I haven't run it yet. I'm going to create a materialized view on this, and I'm going to pick the primary key of card. I'm going to make it a relatively short window. Let's just call it 30 seconds. Recreating the job on start's fine. Don't care about nulls at the moment. Now I'm going to add a query. And when you add a query, basically you're adding a REST endpoint for this materialized view. Let's just call it auths. Let's call it fraud. And we're going to add all the columns to the results. There's nothing we want to filter here. There we go. Just make sure we got all of them. Yep. And then we don't need a filter. So I could also add a filter here. So I could say where longitude is not null or something like that. But in our case, the data is relatively clean, and we don't really need to query by any predicate, so I'm just going to leave that blank. I'm going to save that change. Okay, and so now we have a query endpoint for that materialized view. It's not live yet, nothing's running. So I can actually right click and copy the link address. So that's going to be my REST endpoint for querying that. All right, so let's go and run the job here. So back to SQL and execute. So one interesting thing that SQL Stream Builder does that some folks don't know is that actually we're parsing that query in real time. So if we had bad syntax, if we had a bad schema reference, if we were doing something where the results didn't make sense, the parser would come back and say that's illegal, just like a regular database would. So you don't actually have to wait for the job to be compiled and built and sent out to the cluster to actually get feedback. In my case, of course, since I copied it, it worked fine. And now it's running against the stream. So it's just waiting for messages, sampling messages as they come through, and it'll display some of them on the screen here. Let's go ahead now and create a map. So the next thing we're going to do is go over to the fraud detection observable workbook. If you're not familiar with observable, it is essentially a notebooks interface for D3 and JavaScript. So I'm going to go ahead and just change this previous URL to the one we're using now. And let's just go over and let's just curl that. Let's just curl that and maybe put it through JQ. Make sure we're getting results. Okay, so there's some data. So there's some fraud coming back. And let's just go back up here and we should see our map populating now with fraudulent transactions. So basically, just to kind of lead you through this, this is a D3 representation of a Mapbox map. I've just got a few cells here that are shown in the examples. Let's see here. Let me show you a little bit. This is our map setup for the token for the Mapbox creds. We use D3, and then pretty simple data comes back. We're just taking the raw data like you see here on the left. We're putting it through a function that turns it into GeoJSON. And then we're plotting that on the map. And you can see up here, this map is dynamically refreshing, keeping track of where the fraud is actually happening around the Denver metro area. Now, that data is actually coming from a materialized view. So that's persistent data. If that job restarted, this would pick up where it left off. The other thing to think about here is that materialized views have a time boundary. I put mine as 30 seconds. So you're seeing a 30-second floating window of fraud transactions. So hopefully this explains a little bit about how you can kind of create an end-to-end app super easily on SQL Stream Builder. Here's the results here coming back in tabular format, and how easy it is to kind of create an example from end to end and showing it in the notebook. So hopefully you can use materialized views and you can use SQL to build killer apps on your own.